Alright, back to go ahead and cover vSAN. So what we're going to look at real quick is at the cluster levels where you enable vSAN. So this is also where you're going to go ahead and right click, add a license. You're going to assign the license for vSAN in here. Once you've assigned the license, you've got to have your high availability turned on in order for vSAN to work. vSAN being enabled, it'll start off as just this little blank page. You tell it to enable, and up in this corner, um, it would say turn on, and then as it turns on and enables, you'll be able to start performing your configurations. So here you can see we have deduplication and compression enabled. That is because everything I'm using in this is solid state. You are unable to use deduplication and compression if you're using spinning disks. So when you're beginning your design, take that into consideration because you can get some great storage savings on deduplication and compression. As far as encryption, you will need KMS, so a KMS cluster, in case you lose one, you still have your keys. That is a necessity in order to encrypt. For our performance services, this is going to be a lot of the background stuff, making sure everything is healthy. Now, it pulls a lot of this information, what it's looking for directly off the internet. So if you're on an out-of-band network, you may end up with degraded performance or reporting degraded performance. The vSAN iSCSI target service, this is where you can go ahead and set up an iSCSI network. Your standard iSCSI to a SAN. You'd go ahead and create your iSCSI LUN, your share. You would go ahead and share it out, figure out the multiple paths to get to it. Make sure you have your MTU set up high so that you can do all of that nice data store type stuff. This is a nice one here. This is the new upgrade that I found is the file service. So you're able to create an NFS version 3 or 4.1 share, and you have to give it a domain name. So you'll have a actual unique name for it. For the DNS servers, you're going to want to be able to map it back out to DNS so it can get to where it needs to get to. And of course the suffixes it should look for. Currently we have a single share on here. We've placed it onto a specific VLAN, gave it its normal networking connectivity. Now for the IP addresses, you need an IP address for every member of the vSAN. And then as we have right here, the primary, if this were to fail, the other would go ahead and flip over to 100 to become the primary and be able to be mapped that way. So it does have a failover capability. Not incredibly certain about the timing as of yet. I haven't forced a failure as of yet. And it does have a tie-in to the VMware Lifecycle Management so that when you download all of your patches, you can go ahead and upgrade the version, and it's already been verified that it'll be compliant. So there's a lot of checks in the background about how to upgrade and make sure that you're on the right path. For the advanced options, these are a lot of the deep dive stuff. If you're digging into things like thin swap and large cluster support and stuff like that, it may be time to consider taking a class. So you may be getting in very deep into your storage. For the disk management, we can go ahead and take a look. I have 4 nodes in the cluster, each have 2 disks, and so all 8 of those disks are on version 11. Looking at the disks, you can see that one is the cache tier. It used to be said that you needed 20% of your capacity as cache. I'm not sure if the numbers have changed. I believe it may be down to 10% or something like that. It's just data in flight, and your capacity is your actual long-term storage. When you shut down the system, everything leaves cache. So your capacity right here, that's got 4 of these all set up together across the 4-node cluster, and I have 4 drives that are identical for cache, 4 drives that are identical for capacity. The reason for this is that if you take a look at, not digging into model numbers, but just branding. If you look at something like Samsung Evo versus Samsung Pro, you might see a difference of 953 on the Evo and 970 on the Pro. So you would want to make sure that you have the same models across all of them to ensure a balance in your system. If you end up with an imbalanced system, it's going to go with the lowest number first. So that's how it's going to go ahead and verify, if it's balanced or not, and how it's going to go ahead and stripe it across. Now, that's not to say that it stripes it across evenly by any means, but when it's looking as to how to prepare for a fault, it will identify that. So let's look at our fault domains. Our fault domains, we have a single failure that we can tolerate in here because we have 4 fault domains. I don't necessarily need fault domains because I only have a single host per domain. Even if I had these as individual hosts, I would be able to tolerate a single failure. So what this is meant for is if you were to have a lot of systems that are in your cluster, and I don't recall the limitations, I believe it was something like 64 nodes in a single cluster, you could go ahead and put 16 nodes in this one, 16 in this one, 16, and then you end up with what they call distributed RAID 1. Instead of a random array of inexpensive disks, though, we're referring to it as a random array of inexpensive nodes. So what would end up happening is your 16 here would have a single copy of data striped across it, and then this would be like a disk 2, so it would have another copy of the data or another piece of the data, and then we'd have parity and that kind of stuff. If you want to get up to a failure to tolerate of 2 or 3, then you need to have, I believe, 6 or 7. I think 5 is where you can tolerate 2 maybe, but 6 or 7 is where you start to get into the fault tolerant of 3. And that's where you start looking at what servers are connected to what PDUs and what PDUs are connected to what breakers. Really a physical view into how your physical infrastructure is set up, and then mapping that so that your logical systems are going to withstand any failures in the physical realm. So another real fun part about this is the stretch cluster. So let's say that we've got, instead of 4 nodes, let's pretend we've got 16 nodes here, and this is in one room of your data center. And then up 2 floors and across to the other side of the building, we have another room for the data center that we can go ahead and put a couple wires that are going, super low latency, super high speed, and we can go ahead and stretch that cluster, mirror the cluster, set affinity rules for what's on the clusters. You start to be able to do a little bit more fault tolerant failure capabilities there. If you lose an entire room, or if you have a single part of the building that's on battery backup with generator, then you can have a failover area, and that plays into how you can patch, what your downtime looks like, maintaining maximum uptime inside of your data center. So aside from that, if you really have the money out in the private sector and you want to go ahead and do that super low latency, super high speed to another site, that is also another capability here. Is if you have it all tuned properly, you could do a multi-site with this. Now, the preferred method would probably be using something like a disaster recovery software where you can go ahead and take it up to the cloud and down to the other site, or some type of federation where you're able to manage multiple sites through a single vCenter to make sure that everything has failover, and you can get to all kinds of different warm and hot environments. So let's look into this file service shares. This is the share that we went ahead and built earlier. So just name storage NFS, and we already saw the IP address there. So we can look at it. This is a pretty easy thing to go through. We've got a warning threshold of 300 gigabytes. You can't see it here. I can go ahead and close this up or open up a configuration window, but we have a hard stop at 350 gigabytes on this. So to add a new share, and keep in mind this is always going to be on that IP scheme that you had set up when you built this. So per cluster, I believe you're only able to have that single IP scheme. But we can set up a test environment. We can give it a share warning of 25 gigs and then a hard quota of 30 gigs. We can set up keys and values so that we can go ahead and run some REST API or automation scripts that review those keys and values. these labels, I believe it shows in here. Yeah, you can use them for all kinds of different things. So once that's set up, usually, for your initial, development, making sure everything turns on and works, you allow it from any. Eventually, what you end up doing is going ahead and setting it up so very specific IP sets and subnets can go there. You can go ahead and set up permissions. I believe, yeah, you can just keep on adding and adding and set it up so you have read write or no access at all. So I mean you can get pretty in view here. Get down in there pretty well. So shows what protocols we use, name of it, all of these good things. So pretty easy to set up any new share you want, and then you'll have your standard ability to, let's see, get it mounted and up in your environment. So and there we go. We have it set up right over here in media, and it's just ready to go. So that is the ability to get your NFS shares up and going. So that's a pretty helpful piece right there. Now, if we actually go into the share itself, we want to take a look at the data store. We can take a look at our summary, your standard VMware summary. We can look at capacity, go through the details on it, and it's going to show us what we're using. So 1.59, free space 2.07, adds up to 3.66, right? Okay, so what's actually written on disk is 1.59, but we do have dedupe and compression. So what we're using is 3.67. So we have deduped 2.47x. We have, a lot more on here than physical media, than what the physical media, would hold. We're at what is that? 10 gigabytes beyond what the physical media would normally hold. So that's, like I said, when you're in your design portion of this, you may want to consider what you can save with dedupe and compression, and you may want to have a single cluster that has the ability to dedupe and compress to determine what fits best where. Also, of course, we can also break this down, look at how this stuff is being used, right? So pretty interesting. You're able to dive in fairly deep and get into to see what's going on. I do also like that they've added the cloud native storage, so the container volumes. If you were to look at the Tanzu or Harbor videos, with Tanzu, it's set up, just the master cluster, and then with the Harbor, that's a registry. That we can use to store all of our containers as we build them. So the quota there is 180 gigs. So obviously we can save a lot of containers in 180 gigs that will also end up being pulled down and used inside of the environment. So that's the storage for the containers, and then when you deploy them, deploy the containers, you can also set up additional persistent storage that would show up in here. You'd be able to check its health, make sure it's compliant with any settings that you have for it. So we also have the typical monitoring it, what issues you have here, what the performance looks like. So not bad. What kind of tasks and events have happened. So we drop into the configuration, we can go ahead. My favorite, the alarm definitions. You'll always end up with one thing changing, and you need to go ahead and disable the alarm because you know how to fix it, but you're not going to get to it for 5 days. So yeah, you can put that, disable it. So just your standard alarm task, general information. Now the hardware acceleration, I believe this is a additional piece of hardware that has to be connected to storage that's connected to your host. And so, I mean, you're talking a little bit pricier gear here. So that's something that you'll know whether or not you have that capability before you even worry about why it's on the screen. So permissions are your standard: who's allowed to look at files, who's allowed to make files, who's allowed to copy. And that becomes incredibly important when we start to break down things like this. So if we were to look inside this content library, and we would start to see like ISOs for building out a VM. So you'd want the security to lock people out of ISOs you don't want to give them access to. Especially when you consider they're already in here, are they going to mount that over to a VM and then have access to boot your VM off of bootable media? When we start getting into the OVAs for Photon, so now we're talking about your Kubernetes stuff, you would want that to be incredibly limited to the administrators and the people that manage namespaces. The Kubernetes admins, basically anybody involved with your paths, would be limited here. So looking at permissions, looking at files, when you have your single sign-on capability, mapping all of this out, this is where you can really see the difference. Is like, okay, what are the permissions on this? Why is it that these people are able to see whatever it is they're able to look at? Of course, for hosts, we're looking at everybody that's in the vSAN cluster. So everybody that's in the vSAN cluster includes if you're not sharing disks inside of the data store. If you have nothing to add to the pool but need to be part of the vSAN cluster, the traditional method has always been that you have to go ahead and add on and use your licenses and be there. So with this is who is participating in the cluster that can see the data store. And this is all of the VMs that live on the data store. So you can see your VMs or your templates. But yeah, that's vSAN data store, just in a nutshell. Setting these up, you would be able to set them up with, multiple clusters. So right now I'm in the FunLab cluster. I could set up another cluster that's running with 5 to 6 disks on each of these that are spinners, and just have no dedupe, no compression. They're just there for long-term storage. So it is per cluster, and then also for that file service, we would set up the entire cluster, based on the entire cluster, the IP scheme for all of these. And then looking at, so we have an update here that is available. I'm not going to update it. This is just turned this on, so I want to go ahead and do a little more reading before we find out whether or not we can make it hardware compatible for vSphere 7. But you get the general summary of a VM, even though it's in here inside of this pool. And inside of this pool, as is standard with like the namespaces and the ESX agents, if I were to try to edit this guy, I wouldn't be allowed to. So it gives me the warning. I take a look. Any of the settings that I change in here, give it more memory, give it more CPU, more than likely that's not going to stick, but I can't change the vast majority of that stuff anyway. And we can dig through. You get your normal, what's going on here with all the different piece parts that's on your summary screen. Monitor, same thing. We're going to be able to look at all kinds of fun stuff in here. What alarms have been triggered, how the performance is doing. So down here at the vSAN performance, this is usually where people will start asking questions. The old school admins, hey, what's the IOPS? What's the throughput? What's latency? So those questions can be answered, and that's at the VM level and the virtual disk level. We can also view physical disk placement. So that's letting us know where all of these components are. Standard configuration, so we've got some different rules. We've got the alarm definitions that I love to turn off, different scheduled tasks for the VMs. So if you know that you're going to be taking all this stuff down on Saturday to patch something else, schedule that task. What your policies are. So and you can also log in to these systems. I don't understand why you would. I mean, that's one of those, go pay for a class on vSAN before you start messing around with this, or dive very deep into why you would want to do this before you even think about doing it. This is doing a job. Let it do a job. All right, that's you've got all the logs you need from up here. Once again, permissions, who has any access to this. In general, what I would do is I'd probably hide these guys from everybody and only allow admins to see them. What data store it's using, what network it's connected to. This snapshot piece is going to raise a very interesting question in the near future. So what I'm really curious about is this a snapshot just of this node, or is this going to be a snapshot of the storage? And if this is a snapshot of the storage, then are we going to be able to start offloading snapshots similar to other companies like NetApp? Will we be able to have a cluster here of our file services and then have a cluster elsewhere on spinning disks, large disk for long-term storage that we can dump the snapshots over to and recover from? If we can do that, then we're starting to get into the enterprise file services that, it's might not make very many friends, VMware and some of their partners, but it'd be a nice integration. It'd be a pretty good thing to have. And then, of course, where we started out with the updates, where there's a hardware compatibility update that we could have, and VMware Tools is managed directly on here. This is all handled with VMware Lifecycle Management, so VMware has already checked to validate whether or not the updates need to happen or whether they have happened. Right here you can see that is the common version in Photon. So I believe we have down here on this supervisor. So yeah, we are running a version of Photon there and a version of Photon here. So two different versions that based on what their use case is. So yeah, but that is the vSAN capabilities all together, and that we'll probably end up adding on to this with some of the network stuff that can be done with those file shares. So hope you enjoyed this video.